Welcome to my optional video assignment. I will be using this red pen as a pointer throughout my video. So this was a function that I was given. It's 3x squared plus 5x over x squared plus 1. So the first thing I did was I looked for any restrictions that I had. So I set my denominator equal to 0, and I found that x cannot be equal to plus minus the square root of negative 1. And I know that the square root of negative 1, this is also known as I, which is a complex number. And this tells me that there cannot be a vertical asymptote because complex numbers cannot be vertical asymptotes. They have to be real numbers. Next thing I did was I looked for any removable discontinuities in my function, and I realized that there would be none, so there would be no holes. After this, I tried to find my horizontal asymptote. I knew that there would be a horizontal asymptote because the degree in my numerator and denominator, which is 2 from this x over here, it's the same in my numerator and denominator. So what I did was I took my leading coefficients, which are 3 in the numerator and then 1 in the denominator in front of this x squared, and I divided them to get my horizontal asymptote, which is y is equal to 3. Next thing I did was I tried to find the behavior of my function with respect to my horizontal asymptote. So what I did was I set a very high x value, which is 1000, just to replace x approaching infinity, because this is a very high x value. And I subbed it into my function to get this number over here. And this basically tells me that as x is approaching infinity, my very high x value, the function is approaching the function is approaching 3, which is my horizontal asymptote, from above, because this number is above 3. Next thing I did was I subbed in a very low x value, which is negative 1000, in my function to get this number over here. And this told me that my graph was approaching negative infinity, which is my very low x value. And this was under my asymptote because this number is below 3. So this, my graph was approaching negative infinity from below my horizontal asymptote. After this, I tried to find my point of intersection by setting my horizontal asymptote equal to my function. And I found the x value of my point of intersection, which was 3 over 5. And I knew that my y value of it would be y is equal to 3 because of my horizontal asymptote. So this is my point of intersection that I found, and I just changed this value into decimal form. After this, I found my intercept. So for my x-intercept, I let y equal to 0. So this is my function. I let y equal to 0. So what I did was my denominator would multiply out and my numerator would be left. And then I factored out the x to find my zeros, which are 0 and negative 5 over 3. After this, I found my y-intercept by setting my x's equal to 0. So this is my function, and then I had 3 x's in it, and I set them all to 0 to get my y-intercept, which was 0. So this therefore statement basically just summarizes all the intercepts that I found, and I put them into points just to make it easier for me to graph. So this is the graph I made. This is my this is my y-axis, and this is my x-axis. I made a scale of just 1. And the first thing I did on this graph was I drew my horizontal asymptote. So when y is equal to 3, I made a jagged line to represent my horizontal asymptote. Then what I did was I looked at the behavior that I had found over here, and I tried to graph it. So I said over here that when x was approaching infinity, which is a very high x value, and I just used arrows to represent this, when x was approaching infinity, so it's approaching infinity, my function is approaching my horizontal asymptote from above. So therefore, my function over here, I drew an arrow above my horizontal asymptote. This is my function. The same thing I did for when x was approaching negative infinity, because I set my value to negative 1000, which is a very low value, and I just made an arrow to show that. When x was approaching negative infinity, my function was approaching my horizontal asymptote from below. So I drew my function below my horizontal asymptote, and then this one above my horizontal asymptote. So I just drew arrows first, and then what I did was I put my points on. So this is my point of intersection over here, 0.6 to 3, and then these are both my zeros, and I just connected my points to graph my function. So this is my function, and then this is all the work that I did in order to sketch it.